Hello, I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 5 a.m. on Saturday in Germany. We're broadcasting live from Thousand Oaks, California. It's Asteroid Day. Tonight's episode will be more crunchy news topics, starting with Starlink 2, and then Jeff has a couple of other things for you. We'll be back in 8.3 seconds. Previously, we talked about sources of space news. This week, Jeff will go over one or more articles. I think he found a couple more, which are a bit more substantial or crunchy. And I see we have some comments. Let's go do that first.
Yeah, hi, Janie.
Hi, Janie. Welcome.
Yeah.
Likewise.
The shelling shall begin.
We heard something just a second ago.
Yeah, someone was getting an early start.
And Cliff, who's in Australia, may not understand that is a celebration here we call Independence Day. It is the 4th of July, of course, this weekend. The festivities are bound to start. And hello, welcome. Thanks for joining us.
Yeah, and Scott.
Hi, Scott. Thanks for being here with us. All right, so Jeff, what do you have for us tonight? I'll go ahead and share your screen.
Oh, good. Okay, so. Oh, that's what Jeff does. Okay. So, I did see something about Starlink. Yeah, I saw this article in Universe Today. I just like that image.
It's very cool.
About the new Gen 2 Starlinks, or V2 as they're calling them. Which
version 2, right? Yeah.
I don't think they should be calling them V2, but that's how they write it.
Like V2 rocket?
Yeah, buzz bombs, yeah. Yeah, I don't think that's a good idea, but hey, the new Starlinks are 10 times fainter than the previous Gen 1 ones.
That's pretty significant.
But they're bigger.
Okay.
And we go back up to this picture, and maybe you can see why. They paint them black.
Paint weighs a lot, though. I mean, if you're going to launch something, you're concerned with weight, and
right.
Yeah, even a very thin layer of paint is going to have a weight to it,
right?
Mass, basically.
Right, but they did anodize these, paint them, whatever they did.
Mm-hmm.
Made them black so that they would be less shiny.
Okay, so it's 10 times darker but bigger. Mm-hmm. Does that balance out, or are they actually going to be less noticeable?
No, they're 10 times fainter even though they're bigger.
Oh, I see. Got it. Okay.
Oh, that's right.
Daniel comes in with, and welcome, Daniel. Glad you're here. Buzz bombs were the V1, not the V2.
Yeah, the V1s were noisier.
That's why I didn't understand. Yeah. Thank you, Daniel.
Yeah. So, now one of the things with the version 2 being bigger is that it has more electronics in it.
Oh.
It has more bandwidth.
Okay.
And so, because they're running out of bandwidth in their coverage areas.
Okay, so when you say bandwidth, they probably have to operate, and Daniel probably know. Oh, he's got a comment effect. Pulse jet cruise missiles.
Mm-hmm.
Okay. And Daniel, help us out, because you probably know this better than well, I don't know if maybe you do, but better than I do, how these bandwidths work. Everyone's got their own specific.
Right. Well, it's kind of like Wi-Fi in your house. If too many people are using it, the speed goes down, and that's what they're experiencing. So they're experiencing speeds going down.
That way, all right. So
so they need more satellites up there. Except that they get too many more satellites up there, and they start bouncing off each other. So they made them bigger. Transmit a whole lot more data at a time.
Okay.
So they can use theoretically fewer satellites.
Oh.
But quite frankly, they'll probably end up using the same number just to get more throughput.
So one of the things I remember from when I worked at Boeing was when we were launching the Motorola satellites, we had a certain amount of them that arrived and failed. So I don't know what the failure rate is here. So that's a factor. And of course, some of them will come back down into the Earth's atmosphere. Do you have?
Well, in fact, I had one article where they talked about that, but it was a year old, so it's not news. It just, but yeah, they launched a bunch, and 2 of them came down immediately, or got close enough that they deorbited them.
Okay.
And the rest, they were trying to figure out why.
Mm.
What went wrong in the launch.
Yeah, and this is Elon Musk's operation, and I know one of the things that they're very, very good at is to iterate, and then they test, and then they work it. They test, and they work, and they're very, very consistent about if you're not failing, you're not doing your job.
Right.
Basically.
And Starlinks are a cheap and easy way to fail forward, because
sure, you can learn a lot.
They're not expensive. They've got a bunch of them up there. They can, if only a few of them fail. Well, it wasn't the rocket. If all of them end up in the wrong orbit, then it was probably a launch issue.
Okay.
But if if only a few of them did, then maybe that rack, just didn't shoot off a couple correctly, or whatever, But one of the things with them being fainter is that it's good for people. Can't look up and point to them and go, oh, look, there's a Starlink in my sky.
Yeah.
But a scope is still going to show a streak. It won't just won't be as big of a streak.
Okay.
So actual data collection will still be affected by them.
Oh.
It's just hopefully there'll be fewer of them, but data collection will still be affected, and radio telescopes will still be affected. In fact, possibly more so, because these are transmitting more.
Okay. Yeah, and I know a lot of people that I've talked to they have mixed feelings, because it's cool to see a train of them, for one thing, but it's kind of annoying if you're trying to do astronomy.
But it gets coverage in, say, middle of Montana.
Yes. Yeah, and that's the other side of it, is like I finally have internet, even though I live remotely.
In fact,
which was very hard to do.
One of these is
let's share again.
Hang on. Oh yeah. No. Oh, let me show you this. This is a live coverage map of Starlinks.
Wow, that's a lot. Just Starlink, not all the debris that's in the.
Right. These are just Starlinks.
Wow.
And you see everywhere where you see the little hexagon.
Yeah.
This is Hawaii. This is Australia down here.
Okay.
These are coverage areas. So these are places where they actually are offering coverage. I don't know why. Well, okay, there's not a lot of people in this portion, but that's.
Or in the ocean.
And they have a few going over the poles. You can see.
Is it coverage or subscription based?
So that's where they're doing subscriptions.
Okay.
But,
see, that makes sense to me now.
And you see all of these over the ocean. Well, they just have to be there so that one will be arriving someplace before the last one leaves. So
okay.
So
because they're all basically in orbit. They each have their own trajectories.
Right. Yeah.
Okay.
And these strings are new launches before they spread out. Like this one's starting to spread out some. And
Janie goes, holy moly. Wow, so many Starlinks. Yeah, I was surprised too. I mean, I've heard of launches. I knew they did a bunch at once. This is tremendously more than I expected.
And
have been launched already.
Look at this. Chile has a bunch of coverage, but not Brazil or Argentina.
Well, is that? Do you think that's the subscribers?
Yeah,
so
that's where they're offering subscriptions.
I mean, because if you've got a satellite over a point of the Earth,
right,
you have coverage.
Right.
It's just that nobody's bought it to use it.
Right.
I think.
Or they're not selling it there. I see.
So there's a lot of room for
right.
SpaceX to make some money. Look at Africa.
Because this is not a bandwidth issue. I mean, using these won't slow down anything. Okay. Because you're not using signal. Like over here, if they get twice as many subscribers over here, then they get half the speed.
Ah, okay. Do you know what the red?
I don't.
Okay.
In fact, it's not in any of their there's a fire thing here, and I don't know if that means that
Mm-hmm.
if those are fires.
Mm-hmm.
I don't think so, but who knows?
Yeah.
But look at Africa here. That could be, you notice it's sparse over Africa versus
Right.
Europe and the U.S. because
Yeah.
these are simply on their way to somewhere else.
Mm-hmm. Okay.
They haven't designed this for coverage there.
Right, but there's still quite a lot, even over, it's very far south, and I know we've learned before that 90% of the people on Earth live in the northern hemisphere.
Mm-hmm.
So for as many Starlink satellites that are, it seems evenly distributed to me, even though it's a 90-10 split,
Mm-hmm.
northern hemisphere population versus southern hemisphere population. Interesting.
Yeah, and look at Alaska, which has
Mm-hmm.
have all of these subscriptions,
Right.
very few satellites going over the pole.
Yeah.
So
Interesting.
and this brings to mind this one here. Now, one of the smarter ideas, they're offering it for boats
Mm-hmm.
and RVs, which means that they have to have a way of aiming at you know at the satellites as they go. But
Mm,
that if they get this off the ground,
right.
then that means that some of these areas where there's no one actually using it, they don't have any plans sold, or maybe the boats are using it here.
Yeah.
This is just that they don't have a coverage area.
Okay.
But I think that this is great for boats and stuff because look at this.
Yes.
I mean, those satellites they're heading somewhere.
Right.
So, so that was the Starlink thing. I mean, they're getting dimmer but bigger and producing more radio interference.
Okay.
But you won't see them as well if
Okay.
you're just looking.
Yeah. All right. Interesting.
And so then we go to then I found some other things that because last week when I was looking at the
Yeah. Janie Becker says a friend of ours has one on his boat. He goes to Catalina often. All right.
okay, so that's the Catalina is in the coverage area
Yes.
right here.
Right. Can you zoom into that at all? The sections of the Earth. Oh, you can. Okay. Cool.
Oops. No,
All right.
hang on. Okay.
Oh, and Daniel's got a comment. Let me go with that. Starlink wants to deploy 30,000 satellites eventually, but they are only approved for 7,000 so far. version 2 Starlink uses E-band, which is 60 to 90 gigahertz, and should allow for direct links to LTE cell phones, AIK.
Okay, I can zoom in, but the names on the satellites get
Okay. We got a bunch of comments all at once, so
yeah.
Let me go ahead through those. Scott says, I checked into getting Starlink for my RV, but it was $200 a month. Wow, that's pretty expensive for internet for an RV.
But if you can't get it any other way, then there you go.
Yeah, and if you need it for working, for example, over 4,000 are in orbit. Commercial ships are buying their coverage as well. Oh, okay. So, I wonder if that means like cruise ships are going to have.
I think so.
Yeah, which makes sense. As far as I know. Yep. Thanks, Daniel. That was very interesting. Yeah, 30,000. I mean, you Janie, you thought that was a lot. Wait till they have the full complement. But again, they're going to lose some over time. One of the things that brings things down is actually our sun. It pushes things and they fall, and gravity, of course, drag, all that kind of stuff.
Well, and the sun, if the sun has a hot period, it'll inflate our atmosphere too.
Oh.
And that actually catches low Earth orbit things.
Okay. Yeah, and we know that the sun has increased its solar activity. Yeah, Daniel says, well, they have a 5-year lifespan. Okay, all right. So maybe these will kind of roll over and bring new ones in.
Right.
All right. Do you think that'll get to be longer and longer as they get better and better, Daniel? I don't really know. I haven't looked into this very much.
I don't think so, because I think the whole point of them is that they then come down.
Okay.
They don't end up as space debris. They go up there, they last until their fuel doesn't keep them up anymore, and then they come down.
Wow, 30,000. I mean, it's going to be a continuous refresh of all of them, I should think.
Right, yeah.
Oh, okay. So, cell towers have a 50-year lifespan. Interesting. I did not know that. Have we had cell phones for 50 years yet?
No.
I thought we had them in the 90s. We're getting close.
We had some in the 80s, but they had to be built into a car because, they took up half the trunk.
Oh, okay. All right.
So that was all I found on Starlinks. It's just what last week when I was doing, here are the news sites. I kind of
a couple weeks ago.
Yeah, I kind of rabbit holed.
I did Octavia Butler last week.
Yeah, kind of rabbit holed into a bunch of the news sites. So
very good.
I found a lot of stories.
Hang on, let me share. That's a really cool picture. All right, look at that. Oh.
Yeah. This is, they find a white dwarf pulsar.
Okay.
Because pulsars are generally neutron stars, and white dwarfs aren't neutron stars, so don't generally pulse. Well,
how does this happen?
They found two.
They found two?
Mm-hmm.
Wow.
Basically, if you find one, there's more.
Yeah, that makes sense.
And so they found one, didn't know if it was a glitch, so they started looking for more and found another one. But what it is a white dwarf is crystallizing. And and it doesn't have the mass to become a neutron star, or let alone a black hole.
He's doing the thing.
Yeah. So once it gets cool enough, it starts solidifying.
Okay. Yeah, we heard about the one that's possibly got a diamond core.
Well, that's actually part of this crystallizing process, and that's what I found
diamonds are
in relating to this.
Okay. All right.
Is that so? What they're thinking, and this is that process right there.
There, that's the image. Yeah.
Mm-hmm. But what they're thinking is.
Oh, and you know what? Let me share. I said I'm pointing at it, but I didn't share. Hang on. There we go.
Just let them see it too.
Yes.
Now, it's not necessarily diamond. It depends on what's the most common in there.
Okay. Oh, yeah, that makes sense. Because as a star ages,
if it's sulfur, then it's sulfur.
Yeah, different things will fuse together.
And it's likely a mix, but.
Yeah, because a star is basically helium.
Right.
Helium, then hydrogen.
Well, no, hydrogen, then helium.
Hydrogen, okay. And
then lithium, then walks itself up to iron.
To iron, yeah. Once it's got iron and it burns through that, that's it. It either.
Well, no, it doesn't burn the iron. Once it burns up to iron.
Right. Well, because what can happen then is if you get a big enough star, it will supernova, and then you get heavier things than iron.
Right, and it's possible that a regular star will occasionally produce heavier things, but all the way up to iron, you've got exothermic reactions. After iron, it's endothermic. So you're
tell me the difference.
Exothermic produces energy.
Okay.
So you fuse things into something, and it produces more energy than it took. Yeah. You fuse things past iron, and it takes more energy to fuse them than you get out of it.
Okay.
So that could also cool a star, but it's not a sustainable thing. Okay. So most heavy elements come from a supernova.
Okay.
Because it just bangs and there it's done.
Okay.
But so it'll crystallize here, and the reason why they might be so rare is that they think that it's a dynamo action of the star of the white dwarf spinning.
Yes.
And if it's a mass of multiple, you know, elements and stuff,
Okay.
that's not a crystal. It won't necessarily pick up a charge like that.
Hmm.
Whereas if it's a single, crystal, it might pick up a charge while it's spinning.
Hmm.
And they have this chart here of the white dwarf going around the star, and and it it pulls matter from the red dwarf. If they're talking about a binary system,
Yep.
it'll pull energy from the red dwarf,
Right.
and that speeds up the spin,
Okay.
and that's what charges up the dynamo.
Hmm.
And every once in a while, the magnetic field of the white dwarf hits the magnetic field of the red dwarf, and that stops the feeding.
Oh, interesting.
And then it pulses a pulse of gamma rays and lights up the red dwarf.
Wow.
And they're thinking that that's what the pulse is. And
So it's
since,
kind of the cycle of that.
right. And so it's what they're reading is the orbit is in the pulses. Because when the magnetic field tilts in a certain direction,
Mm-hmm.
it stops feeding and pulses.
Hmm.
And and so that's where and more data needed. They've only found 2.
Yeah.
That's not enough data
No.
to do anything except make explanations, not theories.
Mm-hmm.
They can't test anything with just 2.
Okay.
They can just speculate. It's science. It's science philosophy at that point, not science.
All right.
But then we got into crystallizing stars and talking about star transforms into a diamond planet.
Wow, that's amazing.
And they found one, and um, orbiting. Well, they think they found one
Okay.
that an ultra low mass carbon white dwarf has transformed itself into a planet made of pure diamond.
Wow.
Um, and they found it because it is producing a magnetic field,
Okay.
and it is affecting, you know, things. And they're calling it a low mass X-ray binary.
Wow.
Um, and so this could just be a different form of the same thing that's causing the pulsars.
Okay.
But so it doesn't necessarily have to be carbon. It could be sulfur. It could be,
Mm-hmm.
but if it's carbon, if it crystallizes, well, it's diamond or it's a big
Mm-hmm.
ball of graphite.
Right. Okay.
You roll the dice on that one.
Okay.
And it's possible graphite's more common, and that's why you don't see very many pulsars out there.
Mm.
So that was just an interesting one. I actually found this one first and then found the pulsars
Okay.
just like a few days ago.
No.
But
Got it.
I grouped them together because I think that they're related. I think
Yeah.
they're connected.
Right. Very cool.
And so let's see, how much time do we have? Oh, a couple more rabbit holes that I found. Just because
Oh,
of these images. Super massive
that is so
early
beautiful.
stars.
Mm.
And they're talking stars that would live only for a few million years.
Okay.
At the very beginning, when
Mm-hmm.
some of the first stars. Well, these might be second generation, but they know that.
We keep getting surprised, though.
Mhm.
I mean,
Right.
we don't have any galaxies early on, but they've been finding all these galaxies early on.
Right. Yes. And
We don't know. We really don't know.
and they know because these are massively redshifted,
Mm-hmm.
and they've got very few metals in them.
Okay.
But the ones that they've seen, they're saying are not first generation stars.
Okay.
Their
Interesting.
second generation
Mhm.
are just from the edges of the star formation from the first generation stars,
Hmm.
which apparently, and then they blow up and produce you know gamma rays. Gamma rays are so energetic
Mm-hmm.
that they hit a nucleus and convert into electron and positron.
Okay.
So apparently their supernovas are much, much brighter than a regular supernova.
Oh.
So that was interesting, but it also made me start thinking that the very first, because we have supermassive black holes theoretically
Yep.
at the center of every single galaxy.
Yep.
Um,
oh. Dawn says, can we get the address for that site?
Yeah. Pretty pictures, huh, Dawn?
Yes.
Yes.
Yeah, it's beautiful.
Universe Today.
So let's see, universetoday.com, right?
Yeah, universetoday.com, and we'll put it on there. This is one of the ones that I showed you a couple weeks ago.
Right. Now, did you look for a specific thing, or is this kind of at the top of the pages right now?
This is not at the top of the page. This was at the top of the page 2 weeks ago.
Okay. All right.
And I just kept a hold of it because, look, pretty pictures.
Yeah, that's amazing.
And neat stuff. But it started making me think about the creation of those supermassive black holes.
Yeah.
And was there actually a star there first? Because you had a whole bunch of hydrogen. Basically, the universe was small. There was a whole bunch of hydrogen, but it was packed into a smaller area before.
Right.
So it could compress.
Mm-hmm.
Now, chances are real good fusion happened as it compressed.
Okay, yeah.
But was the fusion the star itself, or was it maybe hydrogen was compressing, maybe forming a black hole with a shell of fusion around it? Where it had compressed enough to fuse, but not enough to solidify. I don't know. It was interesting thought to me.
Yeah, I know they've been searching for the first star, which is an interesting concept to me. I was like, oh, well, that makes sense. There must have been a first one, but I didn't realize
the first ones. I mean, the first generation.
Yeah, I mean, if you had something that, quote, Big Bang, there's going to be, I mean, how stars form is they're from this shock wave. So there would have been probably more than one.
Yeah, but it's always possible that our galaxy was created from the nebula, from the supernova that created our Sagittarius A.
Okay.
Our supermassive black hole.
Okay.
So, the whole galaxy might have been a star forming region in a nebula.
Yeah. We've certainly seen one before from like the Hubble pictures of what do they call that?
One of the nebulas where they had the star forming regions.
Like the Eagle.
Yeah, Eagle Nebula, I think is where it was.
Yeah.
But
got?
Well, here's a link from this article in Nature magazine where they talk about the early low metal stars and
oh, cool.
Yeah, and they talk about percentages of of iron, manganese, and the populations of stars.
So tell me about low metal. Is that few or is that low numbers on the? Okay, so the variety is about the same, but there aren't as many as
it'd be
other generations of stars.
It'd be lower variety just because there aren't as many metals, and there wouldn't be any heavy metals, because
that comes from
the first stars produced some stuff, and and left mostly hydrogen and helium behind.
Okay.
The next ones had that plus some metals mixed in, but not very many, maybe not enough to pick up.
Okay.
Then and it just became more and more saturated. But this is, if you want crunchy, this article right here is crunchy.
That looks pretty good. Pretty technical.
Yeah.
Very cool.
But so this is the article that this was based on.
Okay, and that's probably in there, the link to that article.
Yeah.
Well, I really appreciate that when they, cite their sources and you get a chance to go over there and look at it for yourself.
Yeah, and we can deep dive.
Yeah.
But so yeah, I like the ability to deep dive, and I like when they, like here, this link right here is that article right there.
Okay.
And Universe Today is pretty good about going to their original sources.
Great.
So it's a good high level popular read,
right,
versus this one, which is like, okay, that's a bit dense.
It's okay.
Yeah.
You get them. You get it as well if you want it.
Yeah. Now, this is phys.org, and I talked about that before. They have a space news section. Some of the things that I saw in here were just pretty interesting. And okay, yes, pretty picture, but this is James Webb of Saturn.
That's very cool.
And the reason why Saturn itself looks so dark is because methane absorbs IR.
Right.
And so,
well, and that's one of the reasons we created the James Webb Space Telescope, because it gets absorbed in our atmosphere. The rays get absorbed in our atmosphere, and so this is the same sort of thing, but with methane, right?
Right. Yeah. So we've just got a different view on things. Look at how bright the rings are because there's no methane in them to absorb. Yeah. So
amazing.
It just
beautiful.
Colors will now. And here's a thought. There might be life forms that developed in a methane atmosphere.
Yes.
This is the way they would see Saturn.
Mm.
They wouldn't see the bands.
Hmm.
Yeah. That's just one of the things that I got from this article is just, I mean, this article is about them looking for more moons because they need more moons to accurately describe the structure of the rings.
Okay.
The moons that they have don't produce the rings.
Okay.
In a model. So there's more, there's got to be more moons there, or their models are wrong. One of the two.
More moons that have broken up and created this.
No, just because
the
structure of the rings, see how there's the gaps. Those are created by moons that they're called shepherd moons.
Right. Yep.
And that there aren't enough moons that they found to create those.
Huh.
All the structure that they've seen. So
cool.
So I mean, and this is a lot of just really good news. NASA's Mars helicopter phones home after no contact for 63 days. Because it went behind a hill.
Oh.
And the rover itself was the repeater.
Mm-hmm.
So we couldn't contact it. The rover eventually made its way over there and recontacted, and it picked back up. And it's now functional again.
Very cool. Yeah, it's amazing how well a lot of us predicted that it wouldn't really do much more than its first flight, and here it is, dozens of flights later.
This is kind of interesting. This is ESA is working on a lunar project, and so they went up in a vomit comet, or as they call it, a parabolic comet. But instead of doing 0G, they did 1/6 G. So they're testing. If you see this hand cart, they're testing hand carts for use on the moon. How would they operate? How what's the best design for something that operates at 1/6 G?
Cool. And when he was saying comet, it's an airplane.
Yeah.
What is that? The C something?
Yeah, I see. I think it's a 747.
Okay.
Converted is, I think, what it is.
All right, got it.
But yeah, so that's that was just a neat article there that I saw. Hubble checks on highly irregular galaxy. I mean, again, nifty image in there. This is cool and gross at the same time. They've now got 98% water recovery.
Right, yeah. Well, I mean, if you think about it, the planet does that.
Yeah, exactly.
All the time.
Yeah.
Just the way the whole system works for water.
Right. So their milestone has always been 98% recovery. And they've achieved it by doing a secondary process of because their original one creates a brine. It pulls water and then leaves a brine behind, because you can't filter solid, through a filter. Like, once it gets too little water in the mix, you can't, osmosis it, filter it out.
Okay.
So they simply decided to take that brine and evaporate it and use the water filters in the air to pull it out. So they just made the air more humid and made the water filters in the station, the air filters, do more work. But that recovered another 4%.
Yeah, they were pretty close.
Yeah.
Last I knew.
Yeah. They were in the low to mid 90%.
Yeah.
Which was still really good.
Pretty innovative, actually.
Yeah.
Very cool.
Yeah. And again, lots more articles. These are, I like, they don't have as many pretty pictures on Phys.org, but there's a lot more crunchy articles.
And why don't we grab those and add them to the comments?
Yes.
After the show has posted.
Yeah. And I could find more here, but quite frankly, you can find them too.
Yeah, absolutely.
Yeah.
Yeah. And what's interesting to you folks that you've heard about in the past week or two?
Yeah. And I'll grab this.
Because sometimes, you're way more up on some of this than we are. I mean, you'll see different things than we do.
Yeah.
Oh, good. Thanks.
Yeah. And Phys.org, Space News is only one of the sections in Phys.org. If you have an interest in other bits of science, they've got other science articles.
Very cool.
Yeah.
All right. Anything else you got for us?
No, I think that's it from this. I mean, I could just scrounge a news article and rabbit hole into it for the audience, but
Yeah. This is mostly to pique your interest.
Mm-hmm.
We don't do a thorough thing because it's all about getting you involved. That's what we want. And of course, all those people have come from various backgrounds and doing different things, and that's part of why we do the profiles and have guests. We want to demonstrate how there's a lot of different ways that you can get involved. All right, so I want to do the ephemeris.
Sure.
So some stellar events this week: June 30th through July 7th. June 30th, like we said, is Asteroid Day. That's today. July 1st, Mercury is in Superior Conjunction. July 2nd, the moon runs low. July 3rd is the full buck moon. And July 4th is Independence Day. Also, the moon is at perigee, and Pluto and the moon are in conjunction.
Well, it makes sense. The moon's farther out there, therefore it's closer to Pluto.
That's not what they're talking about. July 6th, the Earth is at aphelion. That's the farthest from the sun. And Saturn and the moon are in conjunction. On July 7th, I'm going to talk about pictures more in a minute. Find us on Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. And Venus is at greatest illuminated extent. I had to look into this because I didn't know what that meant. All right, so let me go there. Go ahead and share the screen. So Venus, brightest now in the evening sky. And I found this from Earth Sky. I get their emails, and this is a fabulous resource. I don't know why it says July 2nd, because it's still a couple days away. But this is an old picture. I think they even say when this is from. Yeah, from March. But I really like this part here. Venus brightest in the evening around July 7th. Venus is the brightest planet, but it's dazzlingly bright in early July 2023, when it's brightest in the evening sky for this year. So this is a really good time to look for Venus. It's in the west before the sun sets. And if you haven't seen it yet, you definitely want to go out and look at it. All right, so let's see. You can't miss it. A lot of people think they're seeing a UFO, actually, when they see Venus, and there'll be more reports when it's where it is, like now. And people, well, eventually they'll catch on. And I'm sure, like, if they call the cops and stuff, oh, that's Venus. I'm sure they know. All right, so look in the sunset direction on any clear evening around now. When it's this bright, Venus appears as an eerily eye-catching beacon. I don't know about eerie. I think it's just fabulous and beautiful. And, of course, when the moon is right there. Oh, so beautiful. It's visible in bright evening twilight as well. Yeah, we've actually gone out and tried to see like when is it visible the earliest, and you could see it quite early.
Yeah, it's a point of light in the middle of the, bright lit sky.
Yeah, it's wild. All right, so Venus will reach its greatest illuminated extent on July 7th. That's when the light portion of the planet just fascinatingly, it's a crescent Venus. It's not even you'll never see a full Venus from the planet Earth, because it's at that point it's
on the other side of the sun.
Yeah, it's behind the sun if it's ever a full Venus. So I did go ahead and click on this. Yeah, you had something?
Well, and if it's a new Venus, you won't see it either. Because,
you might see it if it's across the sun.
It might, yeah.
You'll see the silhouette of it.
Yeah.
If it goes across the sun itself. And that's happened. All right, so this link here, I actually went and did too. But let's go to the end of this. Let's see. Yeah, it's a crescent. If you look through telescopes, and I've tried, and I think you need a pretty powerful telescope to see it. Covers its greatest area in our sky's dome, which I thought was very interesting. I didn't realize this because it grows from 33 arc seconds, and that's the distance across it. And it's an angular distance to 55 arc seconds. Very interesting. And it appears the greatest brilliancy to the eye. All right, so here's this article, and boy, oh boy, this is a whole paper. You can see it's
4 pages.
Yeah, 4 pages. Why does it say 18 there? That's interesting. It might be part of a bigger white paper, that kind of thing. But yeah, I didn't really read into this at all, but I can give you the link because it does talk about what this is, definition, and I think part of it had to do with when they're predicting this. So a lot of the stuff is predictions. All right, so you can go back to the.
Okay, and go ahead and give them the link to this and the Earth sky too.
Yeah, I will. Oh, let me get them in order. All right, so here's the first one. I gotta get to the right place. All right, that's the Earth sky article, and this is the paper for illuminated extent. Okay, so I think those will show up as clickable links for you.
So yeah, so you showed the Earth sky stuff.
Yep.
Okay.
And I think that covers it for now. So yeah, if you folks have any more questions, great. Otherwise, we're going to wrap it up for tonight. Thanks so much for being here. Go ahead.
If you or someone you know has done something interesting involving space exploration, science, or astronomy, we'd love to share our live. Join us again next Friday, July 7th, when Pam will delve into astrophotography a bit and interesting places you can submit your photos of the night sky.
Oh, I actually wanted to show you something too. Oh. Let me go there first. Because this will be part of my, let's start here. Go ahead and share.
Okay. Here we go.
Yep, that one. So you've probably heard us talk about astronomy picture of the day. And this happens to be for today. And being asteroid day, they picked an image of all the orbits of potentially hazardous asteroids. Let me go to this picture here, because that's even more, you can see more fully what, and you can blow this way up. But I thought this was more interesting to see, here in our episode tonight.
Well, and those are the potentially hazardous asteroids that
right.
we know about.
Yes, that's quite so, because we can't see them if they're coming from beyond the sun, from our vantage point. All right, so I am going to be talking about this and also submitting to Earth Sky Community Photos next week, because you can take cool pictures and then send them to both of these sites, and I'll see if there's other ones out there. What the heck? All right, let's check back with our notes. Yep, that's it. Okay, anything else from you?
No.
Anything else from you? We will watch for your comments after this as well. Let's do a shout out. How about that?
Okay, we have
Dawn,
Cliff,
Daniel. Hey, Scott was here.
Scott.
I wish AC would have been here.
Yeah.
He was the one that talked about more crunchy articles, please.
Yeah.
Janie Becker, thanks so much for being here. We said Cliff, right? Did we say Cliff?
Oh yes, we definitely.
Awesome. Thanks so much. We really, really appreciate you. You're our regulars. Oh, you're very welcome.
You're welcome, Jamie.
Have a great holiday weekend if you're in the United States. And we'll see you next week.
Yep.
Thanks a lot, folks. Good night.
Good night.